A useful way to think about the energy of a chemical reaction is to consider the energies released and absorbed by the breaking and forming of chemical bonds. During a chemical reaction, the chemical bonds of the reactant must be broken, which requires energy to be absorbed to overcome the attractive forces of the bond. And the chemical bonds of products must be formed, which releases energy. For us right now, the energy absorbed to break bonds, or the energy released when bonds formed, will be heat. This is a bit of an oversimplification, but it works for us right now. For us, the currency of the energy exchange in a chemical reaction is heat flow. It's also useful to compare the overall bond energy of the reactants with that of the products. The lower the stored potential energy in a bond, the more stable the bond is. Bonds with low potential energy are less likely to undergo changes. We will be comparing the stability of reactant bonds versus stability of product bonds. As an analogy, consider water in an elevated tank. According to the graphic, the water can flow down a slide into a tank that is lower in elevation. The water in the higher tank is farther from the center of the earth and thus has a higher potential energy. When the water has access to the slide, the force of gravity will pull the water down the slide to the tank of lower elevation and lower potential energy. The water in the lower tank has a lower potential energy and can be considered to be more stable, less likely to undergo any type of change. For example, the water will not flow back up the slide on its own. Likewise, there is a directionality with chemical reactions with a tendency of low potential energy bonds, or bonds that are more stable, to form. Products of chemical reactions tend to have lower potential energy bonds than the reactants do.